Today will be on static and dynamic panel analysis, right? In this case, we try to do it using the Stata. Of course, you have other software, but today we'll try to use the Stata, right? For today workshop, it'll be a bit more like practical thing, right? In this case, it's like more not go through the theory of econometric, but more on the step by step to do it style. Okay, so let's start. Here we divide into 4 modules. First, you have the introduction, and then pool OLS mean POLS mean pool OLS. OLS in econometric is ordinary least square. Okay? Then we have module 2, static model, and then the diagnostic, and then after that, the dynamic model. Okay, for this first module, then we'll focus on the panel data analysis from starting how to key in the data into the Stata, then cover also prepare data set, put LS, and then the result interpretation. Okay, so you cover all these 4 aspects: introduction, open and prepare data set, and then pull ordinary least square, right? Ordinary square is used for time series, right? So pull ordinary least square is for panel data. I mean, we actually treated all these time series as one. We just like group together everything and then we run it as a time series. So it's called pull OLS. Then we have result interpretation. Okay. Firstly, you must understand what is regression, right? Regression analysis is a set of statistical process to estimating relationship between dependent variable and one or more independent variable. In mathematical format, we write like, for example, y equals to beta 1, x1, x2, x3, x4, x5, x6, right? So the x is the independent variable. The y is a dependent variable, right? In this case, in this model that we are going to use as example, is growth. So we have something like growth theory or growth model. So in this case, growth is dependent variable, the y, and it depend on this EG, SG, PG, and FO. So this EG, PG, FO, or the X, or on the right-hand side, we call independent. The left-hand side, growth is dependent. Why? Because it depend on the right-hand side. Okay. So then dependent control variable. So what's the difference between independent variable and control variable? For example, if let's say in your research, you want to determine what's the factor that determine growth, so you actually want to focus on, let's say, the 3 only, EG, SG, and PG only, right? This is the main item that you want to prove, right? EG is economic globalization, SG is social globalization, and PG is political globalization. So you want to focus on globalization and growth, right? Then, but there is also other factor that can affect the growth that you need to put in because of due to past literature. Everybody say that, oh, this one also got affect growth, another one also got affect growth. So therefore, you put in other extra variable because they are also will be affecting the growth. Therefore, this other variable you put in, but it's not your focus. Therefore, this other variable we call control variable. So in short, if your focus is only EG, SG, and PG, these 3 will be your independent variable. FO, government spending, and TB, trade balance, is your control variable. Okay? Because if you don't put in the control variable, you have less variable. That means you have under specification. When you have under specification, that means all the influence of your control variable will now go to the error term. So your error term become very big, and then your whole model become untrustable. Right? So this is the thing, right? Then after the regression, we'll do step by step, right? We'll need to see the coefficient in terms of sign, size, and significance. Right? Now, first we go from the very basic, because we some of you or many of you already know how to use the Stata or have done a lot of paper before, but we go through a bit from the starting point where basic first, right? Assuming that we don't know, or you start from 0. So data editor, when you go, I skip from 1 to 1. So when you go to start on the Stata, you'll be like that, something like that. Okay. Data editor is you go to here, can see, right? Data editor. You have two data editor. One, you notice that this data editor bracket browse only. This one is edit. So you got a pencil here. So you click the data editor that can be edit. Right? Not only view only, another is view only. Then you have your Excel file, right? Remember, Stata or eView or any other software, they need to have a certain format for your data. So for this one, you have this like country, let's say Australia, then year, so Australia, year 1986, 87, 88, 89, 1890. So you arrange stuff like that. Then this will be your the first one will be your dependent variable, which is the variable that is like your main variable. The next will be your independent variable, but this one, of course, you can mix it, the independent and control variable, you can mix it. Okay, as long as like that. Then you stack it like Australia, 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 right? And then after that, next country, Bangladesh, 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 stack it everything. Then Belgium, right? You stack it. But okay, something like that. Okay. So how do you transfer the data inside there? You click the first column, and then you go to the last. It's just basically a copy and paste. Everything in, right? Everything in. Then copy. But my laptop here very hard to find back. Okay. When I find back that one. Okay, and paste. When you paste, you notice that you have something here. The first row of the clipboard contain value that can be used as valid variable name. Do we want to treat the first row as variable name or data? Yes. So you click variable name. So you see the first row of your Excel file, remember or not, is your variable name. Okay. In this case, I will advise that you notice the Excel file, you type in or you give a variable name in a short form, right? Rather than in full form. For example, this one. For example, this one EX stand for export. You can put EXPORT export. This one government spending, you can put GOVRNMENT SPN the engine, but no, right? Better to do it in a short form, and then you have another site you describe all the thing in your Excel file. And remember also, when you download the data, especially from the World Bank, you also download the metadata, which give you a long definition. Because at the end of the day, you need to know also what data are you taking, right? For economic globalization, your short form is EG, okay? Then your definition is economic globalization has two dimensions, actual economic flow. So at least you got you know what is this economic globalization. Okay, here we go back to Stata. I got this one. Okay. I got two. Wait, I got two slide show. Okay. See, exactly like that. Okay, prepare data set, treat at variable name, right? Or one thing I noticed there, if you are using Stata higher version, right, there's maybe something wrong with the outrack tool. Sometimes you have to, when you open your right hand click the Stata icon, you have to run as administrator. If you cannot use the outrack tool, later we show. Now you prepare the data set. If your country name all done already, then you don't need to regenerate the name, right? But here, first, you generate code for the country, right? Why? Because country name like Australia, AUSTRALIA, Malaysia, MALYSIA, all this alphabet, the data cannot read. You need to assign a code to the country, like Malaysia is 1, Australia is 2, then Bangladesh is 3. You need to assign the code. But if you assign a code, you have 20 or 30 or 50 country, one by one you assign a code is very troublesome. Okay, so therefore, you use this EGen code. EGen code mean Remember this one? You use the word country to represent this one. This one is in red color. Red color means the data cannot read, right? So you have to generate it. You have to turn the country, right, into code. So you type EGEN code, press enter. Then you notice that you have this one country code 111111111 and then 2222222 for another country, right? 39 Bangladesh, right? Then 333333444 until the end. So the data will generate for you. For this data editor, you can close it. It's okay, right? Then after that, you have to tell Stata that this is a panel data. So when panel data, you use the code XT set. I mean, cross section and time series you set, right? Just now you already generated the country. Now you name it as code. So your country is now use the name COD code. And then the year, you also still use the year, right? If this one you put name and this one you put time, then you get XT name and time, right? So you depend on this one code. Make sure you same with what you have written. Okay. So here we use code and year. So XT set code and year to show that to tell the data that you're using a panel data. So you set. Okay. And then you prepare the variable. Like I mentioned just now, if you didn't prepare in the Excel file, you can prepare in the Stata as well, right? So for some variable, we need to use log form, right? So therefore, now we generate the log form, right? One by one, we explain. So you generate, GN is called generate, the command for the Stata, generate, then LGOV is a name that you give, right? Of course, you can give anything name that you like. For example, generate ABC equals to ln. This one. This one is this variable. Okay. If you don't want to put this one, you can put like that. Generate government spending. Click. Of course, spacing got problem. Then this is the variable name exactly that you use inside the data editor. GOV spend. Okay. This is the name that you want to, the name for the log form of this one, right? Of course, usually we will put L for, we just put an L in front for log. Of course, you can put other name, right? So we generate this one, right? Then you notice that what you generate will actually go back to data editor will be here. Okay, just now we generate code, then we generate this one. Okay? Then you prepare for trick balance, right? So trick balance, okay, we see here. You generate trick balance, I use TB, trick balance. Of course, you can also type TRADE, whatever name you like, but usually we use shorter name because your table, when you generate out, you'll see it's nicer. Equals to trick balance, theoretically, is export minus import, right? But if export minus import, sometimes we have trick deficit, then you have negative. When you have negative, you need to log, you cannot log. Export minus import is also in unit form and in a big, and then you have to log and cannot log. Therefore, another alternatively, we'll use divide ratio. So it's EX here, divided by IM. So if you get 1, that means trick balance. If you get more than 1, higher than 1, that means export more than import. Like trick surplus, you have negative, you have less than 0 point something, that means you have import more than export. So generally you enter, right? Okay, so this prepare the variable. Then usually I would like to put this one, set more off. Why? Because you want to view the output continuously. If you didn't put set more off, after some time, after the screen finishes, then you have to click more. So you show second place, second page. Then after that, if not finished yet, still very long result, right? You have to click more, then you won't have a continuous result. So you click set more off. So you set off the more, it will give you a continuous result, right? Okay. Then basically set, we prepare our data set already. So the next step, sometimes we might like to use summary for descriptive statistic. right? For thesis, for paper, you may not need it that much for journal paper, but for thesis or for report, you may need to have some summary of your data. So you type summary, you enter, you give you the whole summary, right? So all these things here. Okay. One more thing is very useful is you can actually ask the Stata to do a table inside for your summary. So you type the command outrec to. Outrec to is a command to convert this thing into a table form in your Microsoft Word. So using result, this one is your file name. You don't use result, you also can use ABC, XYZ, hello, right? All this. So Word replace some. So it's just like the column, all this, you click, you get this one, right? So for you to see the result, you can click this one. You see Microsoft Word, they give you everything, right? In a table form. Of course, sometimes not so nice, you have to manually adjust a bit, right? Like this one, 1, 2, 3, 4, 5, you may not want to 1, 2, 3, 4, then you have to delete, and then you have to add on, you have to modify a bit. Okay? Okay, so what's so good? Okay. So note that this outrec tool is a command. If you just install the Stata, right? This command may not be inside your package, so you may have to install this command. So to install this command, you have to type ssc install. Everything install is ssc install. For example, you don't have xtset is sure have one. So if you say you don't have, you want ssc install xtset, right? ssc install outrec tool. Any program that you need to use but may not be inside here, or any package or any conversion or any econometric package, you can just type ssc install, right? Then here, as I showed you, you have the descriptive statistic, right? After you run, okay. Now we do the regression. You see, inside the command there for the pool OLS, right? Then you type reg. First is the command. Reg means regression. If you didn't type anything, you just type reg, it's automatically, just now you already set the Stata for, you already tell the Stata that the data you key inside is the panel data. Panel data means got time series and got cross section. It's like Australia, the whole time series for what year, and then cross section also, right? For other country. So if you just type reg, that means they'll run your data just like run your panel data just like your time series. It's called a pool OLS. So you type reg. First variable will be your dependent variable, right? Your y. As I mentioned before, if your equation or your model is y equal to x1, x2, x3, x4, so your y is a dependent variable. So in this case, growth is your dependent variable. Is the variable that you want. For example, maybe you want to see the determinant of growth, right? Or how globalization actually can affect growth. So your economic globalization, SG and PG, right, is your independent variable, right? Economic globalization, social globalization, and political globalization is your dependent variable. This is the variable, or sometimes it's called also variable of interest. You only interest in these three variables, but you also have to put in other variable like FO, like government expenditure and trade balance, because these other variable you search in your literature, you also affect the growth. If you ignore this control variable, the impact of this control variable will go into your error term, and you will cause a misspecification, and your interpretation of result is not accurate. Okay? And so we do this one. Okay. You can put reg, or if you have the thing, you can just copy and paste. I would advise that once if you are starting from beginning, you try to practice, then whatever you type inside here, you copy and paste to a Microsoft Word file, so the next time you can copy and paste and change the variable, right? So here, okay, If you don't want to be like that, you can also have it like that. Okay, group. Let's say you type IG, you can put here growth. Then this now is what item EG, SG, PG, right? And then FO, where is FO? FO is what? Then you forgot, you go back to the legend for financial openness. Okay? Then FO, then after that, followed by government spending and trade balance. So followed by government spending. Don't use this one. Use government spending and then trade balance. Okay? Done. Done. After done, click enter. Okay? Enter. Then you get the result like this. Okay? Here you can either copy like that, right hand click, copy as picture, and then you paste inside. Or copy as table, you paste inside. Right? Or else you use back this one, outright to. Where? Use back the outright to help you to summarize this one. So for example, the comment you don't need to memorize. You can just put in the round of paper and then you copy and paste. So outright to, I just let you understand, is the command or a package so that you convert your result into Microsoft Word using static one dot doc. So this static one is the file name that you give. Of course, you can give any other file name like ABC, EFG, 123, hello, right? Bye bye, doc. So this is your file name. Then usually the first time you use replace, right? Later we use append, right? Replace. So C title, that means the title, the first column title, you put as POL, right? DEC stand for decimal point. So you put 4, that means you're going to give you 4 decimal point. Okay? Then you put enter. You can either click here if you save in a directory, usually save on a Stata file directory, and then you click here, you have the whole thing come out. Okay? So you see the first column, the column title is POL, right? And then you have 4 decimal point. So all the result will be like that. Of course, sometimes you have to, for example, GMM, all this, or you want to do a testing on which selection model, Horseman test, you have to add on whatever you like, right? So you have modified this table. But before you modify this table, you make sure everything run together first. So you have to close first. You have to close first. And after you modify, because you modified, then before you modify before finish, then when you do you put in another full column, you'll be distracted. Okay? Now see here. I copy back the result here. How you interpret the result? Okay? The comment is this one, right? Coefficient is actually your beta. So here you check the sign and the size, right? Right. Sometimes size is not so important, right? Sign is more important. So this one is positive, negative, negative, positive, negative, negative. That means we ignore the significant first. That means this one is EG and growth, economic globalization and growth has positive relationship. Social globalization and growth have negative relationship. Right? Political globalization, PG and growth has negative relationship. So and so on. Government spending also have negative relationship. Okay? Then you see significant or not. If this one is less than 0.01, in this case 0.000, all are very significant, less than 0.01, that means we are significant at 1%. If less than 0.05, in this case is significant at 5%. But sometimes we also can accept, for example, let's say it's at 0.09. If let's say this is 0.09, right? More than 0.05, mean more than 5%, but less than 10%, sometimes we also can accept that it is significant at 10%. Previously, long time ago, you have to set a significant level. Like for example, before you start, you have to set that my significant level is 5%. So whenever you say significant or not, you're referring to the already preset significant level 5%. But now you don't need to preset. You can report, right? this variable, for example, is significant at 1%, this one is significant at 1%, another one is significant at 5%, another one is significant at 10%, another one is significant at 1%, right? So you know to preset. And if what happens if this one is not significant? Not significant mean that not significant mean that if this one is more than 0.10, for example, 0.15 or 0.59, if this one is not significant, whatever number in the coefficient is actually equal to 0. That means no relationship. For example, if let's say EG is not significant, SG is not significant, you cannot say that EG is positively related to growth. Is because this 0.74789 is equal to 0 if it is not significant. But in this case, all significant, right? If SG is not significant, it's also equal to 0, right? I mean, no relationship. Okay? So good. So good.
Yes.
Okay, great. We still got time because we have to cover 4 in a 1 and 5 out 5, right? Okay. Now next is fixed effect and random effect. Just now pool OLS, right? Is we run the panel data as it is like a time series. It's just like we stack it together. But in panel data, you may have one problem. Let's say this time we have so many countries. Each country may have different characteristic, right? For example, developed country, you may have different style. Developing country, different style, right? Different structure, different model, or even some country like big country size in terms of size and small country in terms of size, you will see that their economic structure is different, the political structure is different. So they have their own characteristic. So in this case, we have to take into consideration. Of course, you can use dummy variable to characterize it, but you can also run it in terms of fixed effect model or random effect model. Right? Then after that, we have to choose which one is better. Either pool OLS, fixed effect model, or random effect model. Okay? Then we have a test. Okay? So this is the item that we're going to cover. FEM, fixed effect model. REM stand for random effect model. Sometimes this is called RE model or RE. Hosman test for model selection, right? And then learning guide. Okay. Just now, you remember we do the pool OLS, it's just REG, then everything. Right? Because we treat the panel data as it is a time series. So if you treat the panel data as a panel data, you put XT. XT stands for cross-section and time, right? Then XT, comma, then FE. FE means fixed effect model. Okay? Okay? So we try this one. Okay. Here, one of the good things you use Stata is you can click back the previous command. We take higher. You can click back the previous command and then you just amend a bit. Extract, okay, then comma FE, then done, then enter. Okay, so you see, this one is a command. Show you that this one is a fixed effect, right? Then coefficient, then significant. Okay, so now you see here, EG coefficient is 0, positive, nothing means positive, 0.057058 Okay, P value here is 0.019, 0.019. So in this case, it is not significant at 1%, but significant at 5%. Okay, if you insist on 1% significant level, that means the EG is not significant, right? In this fixed effect model. So if it's not significant in this fixed effect model, this 0.57 is considered as 0, right? 0. So your report will say that economic globalization has no effect or has no relationship with growth. Okay? But in this case, if you use 0.05, it means significant level at 5%, then this one has positive relationship. Okay, this one has negative relationship, right? Usually, like just now in the slide, we interpret the coefficient in terms of significant or not, positive or negative, right? And then the sign, 3S significant, sign, and size. So size usually we don't compare much. If you see economic globalization, social globalization, and political globalization, they are the same type, same index, right? So you notice that both of these EG and PG is significant, positive significant, and the EG is 0.57 and the PG is 0.40. So you can imply that economic globalization and political globalization has the same positive relationship with growth, but economic globalization relationship impact is a little bit stronger than PG because the size is higher, right? But usually the size is not so important. In this case, you just only see the sign, positive or negative. Okay. Now, wait. Again, you can also use this one. Okay. Okay. Outright 2 using, see, same. You must use back the same file name. Same file name. The difference is only this one. Now you put append. Append means that you add on one more column inside there. And that column title, C title, the column title, you put FEM. Of course, you can put AVM, FAM, GM, but in this case, you are running fixed effect model and then the common term for fixed effect model FEM. So you put FEM, decimal point 4, right? So the difference is you put append, that means you add one more. Column title, you give a column title, okay? Then you put enter. So when you look back at this file, you add one more column there, right? And then it's FEM, okay? So you'll be like that. So okay? Then, now, next, you can see here probability test, right? This probability test, H naught is pool OS is preferred. So you look back at the result. You look back at the result, right? Look back at the result. So F test where all this one is your probability test. Okay? And your probability test probability is 0.00000. That means it's significant. So when it's significant, it means that H1 FEM is preferred. Okay, so you see the bottom line table, F test, this one, this wording. Okay, remember this wording. Okay, then you see this wording, right? So significant mean that compare the fixed effect model and the pool OLS, fixed effect is more preferred. Okay. Now next, we run the random effect. Random effect, you can go back to here. You see, you click the command come out. Random effect only different one alphabet. F you delete, you put R. Random effect. Right? So enter. So you get the random effect model. Okay? So here show you random effect model. Many of us actually do not realize that this random effect model actually are using GLS regression, generalized least square, right? And if you use generalized least square, you got your life will be a bit easier because you do not follow some of the assumption like autocorrelation or this thing because then it's easier if you have if at the end of the day random effect model is selected, you'll notice that your diagnosis test actually no need to test certain item, right? But anyway, so you run out this model, you also interpret the same, right? Interpret the coefficient in terms of significant or not, then the sign, positive or negative, and then the size. So in this case, you see here, this p value 0.42, so not significant. Therefore, this political globalization, whatever number they put here, either positive or negative, we just say that it's not significant. Not significant in this case means equal to 0. Okay. Also good. Fixed effect model, random effect model. Okay. So do back the same thing. You do back the same thing. Like that lah. Okay. Now after you run the model, you click outright to, okay, see, I click back the same command here, append, because you want to add one more column. So this column, you put random effect model. Okay, just change one alphabet. Okay, and then you enter. And you click this one. You see, you add another another column here. Okay, and then this one is your C title. Then you also got 4 decimal point, right? Automatically it will show you if silicon at 1% is 3 star. Just now political globalization is not silicon, so here no star. Okay, you close this one first. Okay. Then okay, next XTZ0. Okay, just now we have test a competition, okay, a competition between fixed effect model and random effect model. We see this one, right? Then the answer is, or the result is significant. Significant means fixed effect model win pool OLS. It's just like a football match, right? So this fixed effect team beat the pool OLS. So 1 point. Okay. Next, you have to test XT test. You enter, right? This one is called Bush-Pagan-Langerian multiplier test for random effect. So this test, if H0 means if it's not significant, then pool OS is preferred. If significant, then random effect is preferred. Just like similar like just now. Okay. So now you test, you notice that the result here, you see, probability. So the result, this one is significant. So significant, who win? Random effect win. Okay. So in this case, we already have 2 mesh, right? Pool OLS lost to random effect, fixed effect 1 time. Second mesh, pool OLS also lost to random effect. So very clear cut. If this one is like a football match, the pool OLS has no chance to further progress, right? Because lost 2 already. Right? Now fixed effect win 1 time, and then random effect win 1 time. All right. So now who is going to be the champion? Okay. Okay, so this one you see, pool FS win 0 time, fixed effect win 1 time, random effect win 2 times. So you're going to use the Horseman test to determine who is the champion. So you're going to have a match between fixed effect model versus the random effect model. Okay, how you do it? You read step by step. First, we go through this one first. First, for the Horseman test, H0 mean RE is preferred. In other words, mean after you run the Horseman test, you get the result, significant or not. If not significant, that means RE, random effect win. If significant, I mean fixed effect win. Okay, how do you do it? First, you have to rerun the fixed effect model. And then you have to ask the Stata to store your fixed effect model inside its temporary store first. Then you rerun the random effect model. So in this case, you have already stored the fixed effect and then compare with the random effect, and then you type the Horseman test command, Horseman fix. Okay, we try. Okay. So first, you run the fixed effect first. You find back the fixed effect. Where's the fixed effect? This one, right? So you click here, fixed effect model. Okay, click. You run the fixed effect model, and then you key in the command EST, estimate store fix. So EST. So you store the fixed effect. I mean, you don't ask the Stata remember this fixed effect. Then you run the random effect. You can actually put back this one and then delete or you find back the random effect. Right? then you key in the command. Command is Horseman fix. This is the command, and then you enter. Now, the result is probability 0.0000. That means significant. Significant mean fixed effect model is the winner. I mean, fixed effect model is more preferred, right? Just now we see if H1, that means significant FEM or fixed effect model is more preferred. So therefore, now you have 0 win, 2 win, and 1 win. So in this case, mean 0 win, now fixed effect versus random effect, use the Horseman test, then fixed effect win. So when fixed effect win, then we rerun the fixed effect. Okay, yeah. So you can see here the effect here. So result is significant or reject H0, thus the FEM is preferred, right? So if you reject H0, FEM is preferred, fixed effect model is preferred. Okay. So far so good. Okay. So here are some of So some of the useful guideline, right? Stata help file, you can go to Stata help file, or even in the Stata also you can have a help section here, right? So you can find the help file here, and then Stata list, Stata forum. Sometimes you type inside there, sometimes you might get answer or Google, and then again in self university in my last previous training also I got give this landing guideline. Okay, so this we stop here for a while. Diagnosis test, okay, and remedies. First of all, we choose already. This module will be focused on diagnosing the problem of the chosen static panel regression model and then the possible remedies, right? So it cover all these standard diagnosis tests, heterogeneity, serial correlation, cross-sectional dependence, and then time effect, right? And cover commonly remedies for robust cluster. If static fixed effect is very simple, only usually you just run robust cluster, then everything will be done. Just like you have fever, then sore throat, headache, everything. Just take Panadol, then finish, right? Or just take antibiotic, so finish. Just take one medicine enough. Okay, right? So these are the common diagnosis tests. But before we go far, just now remember we choose the fixed effect model, right? So when we choose the fixed effect model, you might understand what is fixed effect model. Fixed effect model is run based on certain assumption. We won't go into detail on this assumption, but because it run based on certain assumption, so this assumption must not be violated. And you can also already guess what is the assumption that this fixed effect model is based on. First, they're based on homoscedasticity. They're based on the assumption that there is no serial correlation. They're also based on assumption that there is no cross-sectional dependence. So they're based on these three assumptions. And of course, you must also ensure that there's no time effect. For example, if you do a time series data, let's say from 1990 until 2024, then most likely you have a lot of problem, especially during the COVID year 2019. Now COVID-19, so 2019 is December, won't have anything, so you will have a problem with 2021 when there's a lot of lockdown and the whole global economic crisis. So you may have a time effect here. Of course, you can put in dummy variable based on your experience, based on your estimation, or maybe 201, 2020, and 2021, you put a dummy variable thinking. But of course, you can also put in all the time, that means the time from start until the end, so you see a time effect. Okay. Now, next, what is heterogeneity? It means different variance. So bias estimate of standard error. Heterogeneity will cause your standard error to be biased. If your standard error is biased, then it invalidate your statistical test of significant, right? Because how to say your significant or not significant actually also depend on your standard error, because your t statistic, your t statistic is based on your coefficient. The coefficient there by standard error. So if the standard error is wrong, then your t statistic is wrong. So when your t statistic is wrong, that means even though you say it's significant or you say it's not significant, it's a wrong answer, right? So we must ensure that the fixed effect model do not have heterocardicity problem, right? In other words, mean the fixed effect assumption of homocardicity is not violated. Okay? So how? You rerun the selected model. In this case, we go through this one later, only we rerun. We have the fixed effect model, right? So the fixed effect model, you rerun everything. Just now is xt test 0, so this one is xt test 3. This one 1, 2, 3, 4, 5 is not fixed by me. The command package already has fixed like that, right? So again, if you run xt test 3, cannot run because you don't have this command package. You have to do ssc install xt test 3. You install the xt test 3 first. Of course, you need internet connection, right? So you install xt test 3 first, then only you can run this one, right? Some of the testing you don't have, then you just have to install first. It's still free. Right? So testing xt test 3, then you come out with this one. Modified old test for group Y heterocardicity in fixed effect regression. Then you get probability 0.00. Very easy to remember because when I first, my slogan is make difficult things simple, right? So I usually use this approach to teach students or teach other people for training. Make difficult things simple. When I first learned about econometric, I was very confused. Reject mean what? Reject mean good or reject mean no good, right? So now for diagnosis test, right? Anything that reject mean no good. Why? Because H naught mean nothing, right? H naught mean 0. Like just now the correlation beta, H naught mean 0. If this one is do not reject, that means you do not reject H naught, that means 0, nothing, that means homo, good, good. Just like you go to your clinic and do a blood test. If anything that got red color, reject. Probability, yes, significant. Wow, high blood pressure, yes, significant. Cholesterol, high, yes, significant. Sugar level high, yes, significant. So all the significant is no good. So when you have diagnosis test, anything that highlight by the doctor significant is no good, right? So in this case, your XT test 3, right? For heterocardicity, significant. That means no good. No good means there's a presence of heterocardicity, right? Never mind, it's okay. Next, you test later we test one by one. Serial correlation, right? Serial correlation means auto correlation is the same. So it's a relationship between a variable and its lag version over time where they should be uncorrelated, right? For example, let's say inflation. If last year inflation, this year most likely will have inflation or at least will have some impact of the inflation, right? So in this case, your last year actually correlated with this year. Okay? So something like that. So in this case, in your fixed effect model, the assumption is independent between last year and this year. So nothing. So if therefore you have to test the diagnosis test whether it's true or not. Okay? So if it's correlated, then you have to do the remedies. How to test the serial correlation or auto correlation? You use the LM test for serial correlation. The command is xt serial. So again, if I'm not sure whether some are already pre-installed, some do not have this command. If you don't have, you just put ssc install xt serial and then you enter first. Let it install first, then only you type this command. The first one is a command. The subsequent one is your equation. So growth dependent variable and then control variable. So after you enter, again, your result is significant. Significant mean not so good. Significant, yeah, now testing serial correlation or auto correlation. Significant mean you got auto correlation problem. So just now we got heterocardicity problem. Now we got serial correlation problem. We got 2 problem already. Okay. Another question I want to ask is, if just now the selected model is not fixed effect model, if let's say selected model is random effect model, because I was also been asked this question. When their selected model is random effect model, then they try to test the serial correlation test, come out error, something like that lah, error or no result. Why? I mean, if your selected model is random effect model, you test the serial correlation error, because you remember just now the random effect model, they use GLS estimation, generalized least square. This generalized least square do not have this assumption of autocorrelation, no serial correlation. That means you don't have this assumption. That means you run the random effect model based on GLS estimation, which no need this assumption. That means this serial correlation got or didn't have, also never mind. So in this case, you don't need to test this one. If test also result come out, something like error or comment 134, something like that. Okay? So fixed effect model need to test this one. So the result is significant. Significant. Just now, any diagnosis test is significant mean no good. Right? So next, what's the next thing we have test? Why cannot? Okay, so okay, maybe we try. Let's try these two first. Cross dependent, right? Cross section dependent actually is a causal effect of one independent variable upon the dependent variable at a given point of time. Something like it will disturb side impact and make the model not so correct. So it can lead to misleading interference, right? So that's the cross-section dependence. This one is not more serious compared to heterocaricity and serial correlation, right? So you use another command XD again. If some of your package or your Stata not yet have this command, then you have to type SSC install XDCSD. So you install, after you install, then only you can run this one. Okay. So you type the exact wording XDCSD, persaran ABS, enter, then you get the result. Reject H naught mean has cross section. See, every time reject is not so good. But here, here the result is P is probability 0.0000. They mean very significant. So reject H naught. Significant. Significant mean you have this model also have cross-sectional dependence. So this model, fixed effect model, by right, it should be free from heterocaricity problem, free from serial correlation problem, has no cross-sectional dependence problem. But unfortunately, this fixed effect model has all these three diagnoses. Just like you diagnose someone, by right, a healthy person shouldn't have high cholesterol, shouldn't have high blood pressure, shouldn't have high sugar content level, but these three also has, right? So how? Then of course there's a remedies, right? So we try to do it on the Stata first, okay? One by one. So run heterocaricity problem. So you have to rerun the selected model. So just now selected is fixed effect, right? Where? Okay. This is the selected. You can choose back from here. The good thing is you can choose back where this is selected. So you rerun the whole thing. Then just copy and paste. Or this one is XD3. You can also type XD3 lah. Okay. So enter. You see probability significant. Then for serial correlation, so you see also copy and paste from here 0.002, right? Significant mean there are serial correlation. For cross-sectional dependence, if you have all the comment you put in your Microsoft Word or PowerPoint, you just need to copy and paste. Oh, you see, last estimate is not XT right, because our last estimate is XT serial, right? So last estimate not ST, so cannot. So therefore you have to estimate back the ST right, for fixed effect. Then you put back this one, 10. Okay. Probability significant. So you have these three problem. So it's okay. Then next. Time effect. Some researcher or student, they will not like to test for time effect. They just want to, maybe for example, they do structural break. It's a more high level thing, like for example, COVID. They want to see the impact of COVID, or maybe they are not focusing on the impact of COVID or impact of certain event. They'll just put a time, but they acknowledge that there is a problem during the COVID time. COVID-19 mean 2020 and 2021 is a extraordinary. Maybe it's not our normal scenario of economic. It's a special scenario. So you put in a time dummy whatever for 2020 or 2021, because COVID-19 start at December 2019, but that time to December, that time almost nothing impact. So the next impact will be 2020 and 2021. So you can put dummy variable, or you can straight away put test the time effect. So cross section dependent. This one I think okay. This one you tabulate here. You generate a time dummy. You type this command, tabulate year, and then generate T dummy, right? So generate a time dummy, then test every one way or two way. So you put back this equation, and then this command, test palm I year. Okay, we do one by one. This is a step by step, right? First, you have to generate the time dummy. You don't need to generate by manual. You can generate by command. So you put this command, right? Okay, before that, we see here, nothing, right? This is the error term, right? Nothing, right? Then you generate this one. Here, I think got show inside here or not. You see, time dummy. One for this year, and then all 0, 0, 0, 0. Then this one for second year, all 0, 0, 0. This one for third year, then the other is 0. Right? Of course, now I say that, or maybe you think that let's say 1990 is a problem year, special year. So you want to generate a time dummy for 1990, then you put a time dummy variable 1, and then the rest is 0. Or you think 1990 and 1991 got problem, the rest is no problem. This 1990 and 1991 has a special a bit, got some event or got shock. So you put 1, the rest 0, 0, 0. But here they automatic generate dummy for every time dummy for every year. Okay, time dummy for every year. Okay, auto one. Okay. Close. Okay, so all this generate everything. Then next will be you run back the fixed effect, but this time with the time dummy. You notice what is the difference? This one, I times year, right? This is the only difference, right? For the, you delete this one is exactly the original fixed effect model. So you add this one for time dummy, you enter, then you notice that see back the p-value, okay, for the time. Not significant, not significant, not significant. This one 0.02 is significant at 1%. This one 0.01 also considered significant at 1%. So 1991 and 1992, there may be some event that happened that caused you to have a slightly negative impact on the growth. Not sure 1991, 1991 happened. So in this case, you either ask a ChatGPT, or you Google, or you ask Wikipedia, you type 1991 come out, then it will give you all the significant event happened in 1991 and 1992, or you ask the ChatGPT. 1993 also as well. So not sure what happened in 1991 to 1993 that give you an impact of these 3 years. Right? Then the rest nothing. Then 1998, this one should be most likely is a Asian financial crisis lah, because 1997, 1998, so it's an Asian financial crisis, right? And then this one 2021. This one I forgot what crisis already. I think global economic crisis or what. Then this one, if you want to have this 0. This one is a good example. Where is that one already? 0.052. If your tolerance for significant level is up to 5%, right? No more, right? You don't take 10% as a significant. So in this case, this year is not significant. But if you are okay, 10% also acceptable. That means this year is also considered as significant at 10%. Okay, then another few more year, right? 2028 and 2029, and again, these last 3 years basically also significant, right? So you can interpret what event happened here, or at least if you don't want to interpret also is okay, because the impact of these few years that is significant is already captured inside the model. That means all this coefficient that you get, right, is already taken into consideration the impact of that happened during that year, even though you don't know what happened. So then it's okay lah. Then you test, or just now test already, right? Not yet. Oh, you still can test this one. You can still test it out. Basically, you see probability is significant. As I mentioned to you, all the diagnosis test which is significant mean you got something, right? Something is that the problem is significant. Right? The diagnosis problem is significant. So test pumps significant. Overall, there are time effect. Of course, you see the result here, so many years significant. If one or two, maybe your overall model become not significant. But here, from here, you already expected significant because 1, 2, 3, 4, 5. If this one you ignore 5, 6, 7, 8, 9, about 10 years significant. So in this case, before you test the result, also you already expected significant. Okay? So up to you whether your final model you want to include all the years inside or not. Right? You had include all the years inside, but not need to explain one by one also okay, because you include this one mean that your model, your result here already take into consideration all these shock event or extraordinary event happen during that particular year, even though you don't know what is it. So it's okay because it already take into consideration for this model. Mm, mm, mm. The result is like that. Okay? Any shock on this particular year, right? Now, the remedies, right? Just like say, just a fixed effect model, just now got a few problem, right? Actually not few problem. In this case, you have a lot of problem, right? It's okay, right? It's okay. In econometric, in time series, in panel model, fixed static panel model, you identify the problem. Now you have hetero serial correlation, we have hetero, then cross section, and then two-way time effect or just time effect, right? But you have a all-in-one remedies as follow. For now. For a while. Okay. Then what is the all-in-one remedies? You got a lot of choice. You can run the feasible generalized least square. If generalized least square, at least is you general least square compared to the FEM effect, they relax some of the assumption. That means this hetero serial correlation, you don't need to care much, right? So you use XTGLS. GLS, remember or not, the random effect model. If you can recall the random effect model that I purposely highlight to you, you use GLS estimation. GLS estimation, they don't really follow the normality assumption. So in this case, you can relax some of the assumption. Right? You use them, or you use a panel corrected standard error. Right? So in this case, you have some certain standard corrected panel corrected standard error. You use this command XTPCSE, but some of these remedies or some of these methods, you need to fulfill certain condition. For example, you want to run the FGLS, T must be more than N, because GLS is more like a time series, so your T must be a lot. So in this case, it will not be so appropriate. So panel corrected your N more than T. So you depend on you which one, right? Or to be more easier, if you choose this one, run the robust plus cluster plus time effect for the FEM. I mean, robust means you take into consideration of this hetero, serial, cross-section dependence. You do something in your regression, automatic one, right? Then okay, so when you come out, if your answer in your result come out, is already taken into consideration of this one. Right? For example, you take into consideration of your allergy, your medical history, your heart attack or not, heart attack or not, heart cholesterol or not. So the doctor will just give you a medicine all in one. After you eat this one, everything settled, right? So how to run this one? Again, you can see the pattern. You have XT-REC, stand for panel data command, right? XT is panel data, right? REG is time series, so XT-REC. Again, the equation, growth, EG, SG, PG. Growth is a dependent variable, your Y. EG, EG, SG, and PG is your independent variable or your variable of interest. But you also have other variable, you call control variable, that you have to put in, but you're not interested. Right? FO, the government expenditure, financial openness, government expenditure, trade balance. Then you also include the time effect, right? So you put the I time here. So you already include inside, even though you do not know what happened in that year, but you already take into consideration, at least econometrically, you take into consideration, run the FE. So this one is your standard regression. Just add one more, few more words here. Robust cluster country, right? You just add these three words here. When you click enter, the result come out. You can justify that. Oh yeah, we have the regression. Our regression model, FEM fixed effect model, has this problem, but it's okay. The model that we run, we already consider this problem, so we run a robust cluster country. So you can interpret the model based on the adjusted robust model, right? And then you present your format for easy comparison. Remember or not, we have the outrec 2. So you just took another outrec 2, you add another one more column, your robust FEM model. Okay. So after you click, you'll get like this. Can I get your comment is this one? Remember or not? Your comment is this one. Then you get this thing. So fixed effect, regression, coefficient, right? Whatever. Of course, below there you will have a lot of this, all this lah, right? It's okay. So you interpret as like usual, p-value. So economic globalization, in this case, after you take into consideration all this diagnosis problem of the heterogeneity, autocorrelation, and then all this thing, right? You take into consideration already, then this economic globalization become not significant. P-value is 0.179, right? So not significant. Not significant means that economic globalization has no relationship with growth. This coefficient, even though it's 0.0669186, got a number here, is actually equal to 0, right? So this one is significant at 1%, PG significant at 1%, financial openness significant at 1%, government expenditure significant at 5% because it's already over 0.0. Then this one is trade balance is significant at 1%. So then whenever there's significant one, then you can interpret the sign. Remember not how to interpret the coefficient, interpret in terms of sign, size, and then significant. First of all, you must see the significant first, right? So if, for example, this one significant, that means social globalization has negative relationship with growth. The higher the social globalization, the lower the growth, right? Then for what reason? Any other literature give you the same result or similar result, right? For different country, different year. So this one is your right up. So we will touch more on that one. Political globalization have positive relationship, right? So in this case, if positive relationship, that means your policy implication, you must promote more political globalization, but reduce social globalization. Economic globalization, in this case, no effect. But despite that, despite that, many theory, many assumption, many people who believe or expected that this economic globalization is positively related to growth. That means the more your economy globalized, the more is your growth. But in this case, you see no effect, right? Zero, not significant. Then why? Then in this case, in your write-up or in your result discussion, then you have to find out, or you have to give your opinion, or you have to cite whether this result actually is consistent with other paper, or which paper, and then why. Maybe for Malaysia, or for this type country, or for this situations, it's like that. So you give a reason. Okay. Then the year effect, of course, the result is very long. Later we try to do this one. Come out like that. So you, in this case, you see some of the year are significant. Then it's up to you whether you want to find out what happened in this 1991 to 1993, 1998. Most likely is Asian financial crisis, right? Because of Asian financial crisis, the thing, your whole model get affected. You know, regression is like you plot all the data and then you try to draw a line that most represent the relationship. Let's say X and Y, X and Y. You try to draw a line, say draw a line like that, most represent the relationship. But maybe in another year, is above, right? So something wrong with this year, so you have to take into consideration. For example, if you're a student, every extra hour, every hour you put in, you earn you extra 10 marks, right? So you extra, you study 2 hours, you get 20 marks. You study 3 hours, you get 30 marks. You study 4 hours, you get 40 marks. But when you are sick, you study 5 hours, you cannot concentrate. You only increase 10 marks. So that time when you're sick is like something shock happened here. So you have to take away, or in your model, you have to consider this situation, or when you are sick, you will not follow this normal pattern, right? So when you do a dummy variable here, the model is actually capture that thing. Okay? Understand, right? Okay. Now we try to run this one. Run this one. So same thing here. Okay. Again, you notice that from here until here is exactly like you run this one, right? Exactly the same. Okay. And this one is already taken into consideration the time effect, right? Every single year. Okay. Now, because when we do this model, the fixed effect model, diagnostic tests actually come out with a lot of diagnostic problem, like hetero serial correlation. So therefore, we all in one put a robust cluster adjustment inside. So when this one, then you just enter, the result come out will be adjusted, right? Will be automatic readjusted. So you interpret based on this part, right? Of course, this part is optional. If you want to interpret this part as well, you might want to try to find out what happened in 1991 to 1993, where these 3 years actually give you a significant result. Something happened in 1991. Of course, as I mentioned just now, nowadays you can use a ChatGPT, or for me, I still use the Google. I Google or use the Wikipedia. Type Wikipedia there, you type year 1991. Major event, then they'll list out everything for you. Then you will see what's the event happened that caused this year. Or you can also ignore this year because you already take into consideration, then you interpret based on this one. Then will be fine as well. Okay? So interpret based on the adjusted robust cluster. Oh, before that, you can also do like that. Just now, remember Stata, one thing is you can see this side, this area, right? This area, they got a lot of comment that last time you put inside one. So you can put back this one. You see outrec to using same file name, append, that means you add on only. You can put fixed effect dash maybe robust, right? So you enter, then you get a new column, right? Of course, this one's very long, very long. So if you don't want to do this one, you can always manually delete it, right? And of course, just now the impact of the diagnostic, not the choose model one, you have to put in the fixed effect Houseman test, all these things you have to enter, you have to modify a bit the table lah. And this table, do not modify until you finish everything. If you modify, then I believe that something will wrong, then you cannot continue to append. Right? You do not modify until you finish everything, then only you modify. Therefore, it's important for you to know this result. For example, XT test, the Houseman test result, right? Your significant or not, the chi-square is how many, then all these result, XT test result, right? Chi-square, how many, the probability, the result for probability for chi-square, how many. So all these are important for you to check back. It's good for you also to do like that. Usually for me, my practice is I copy as picture or copy as table. Usually copy as picture is okay lah, because you just want to have a number. Copy a picture, then you open a Microsoft Word file, you paste everything inside. Later, also can do one more thing is you paste everything inside one by one. Later, one thing is see the file here, click the file, okay? Of course, okay, wait, click the file, print result. Print result, in this case, you can put it cube PDF, right? So you print, either you just can put anything, right? Okay. Okay, we just put let's say desktop. Then C D E F. You save. Then when you open back the desktop, right? You open back the desktop, and then we can open the desktop. Then you'll see back the thing. You see back the thing out. Where's the desktop? So you have back all the result that you done do just now. Every single thing, include your error or whatever, so all come out here. So therefore, when you want to copy back the test result or whatever, you can see back, right? And you can also use as a reference point next time. You just copy and paste, right? Copy and paste, you just change the variable. But actually, if you want, you know the format, then it's very easy. Just XT and then RE or FE in the middle is your equation, right? Remember, dependent variable first. It's important. The arrangement of the variable is important. The first one must be dependent variable, the y, right? Followed by independent variable, and then only control variable. Right? So again, you see, I copy and paste the result here. So you interpret based on coefficient, dependent variable, independent variable, then time, all this thing. Okay. The module 4, static model, you have FEM and IEM, who I also consider as static model. Right? Static mean what? I mean, on that, the difference between static and dynamic model, dynamic mean you actually consider the lag effect, like mentioned just now, the previous effect. For example, usually I think most of us, even though we are lecturer or academician, we have been student before, right? So when we go to exam, right, the first exam usually is very excited. And then the second day also, let's say we have exam on the consecutive 4 day. The first day exam, if you go inside there, then oh no, the exam is too hard. I think it's going to most likely fail, right, for the first paper. Then you affect your second paper tomorrow exam. So go back at home. Then at night also you cannot focus on study, cannot sleep. Ayo, I think I failed my first paper. Ayo, no hope lah. Most likely bye-bye lah. So in this case, you see your past event actually affecting your future event. That's why I always advise students don't need to take care of your past event, past result lah. Because if you fail also, you cannot make it pass. You pass with flying color, so you cannot make it fail. So just biar lah. Right? So in this case, you have passed thing affect your current. Therefore, you have to take into this consideration. So all these past effect affect the current. The technical term we call here is auto correlation. Like just now, we have the serial correlation, right? So therefore, if you have serial correlation, you have to take into consideration of this one, right? So therefore, you have a dynamic model, right? So this model focus on the dynamic panel regression and analysis. It covers the two generalized least square method, GMM. So we have two. One is dynamic GMM, one is system GMM. If you see the difference and the command and the regression function, right, is only one different only. One got NOL, no linear regression. One don't have. So dynamic and system GMM as well as method for other model selection. Okay. So we cover what is dynamic model, like I mentioned just now. We try to make difficult things simple. It's like that, right? So these two model how to run, and then like as usual, just now we had 2LS, fixed effect and random effect. Now we have DGMM and SGMM. Which one should we choose, right? Okay. First, we have this endogeneity problem. So your independent variable is no longer independent, it's correlated with the error term, right? Or in commonly we say you are affected by previous item. So you have this called, we won't go into technical, we call nickel bias. But of course, if you write a paper or write a thesis, you have to somehow write this term inside, right? Nickel bias lah. If let's say you choose dynamic model, then your examiner or the reviewer will ask you why you choose this model, right? So you have to write some at least some technical term to impress or make sure it's don't have any technical. So this nickel bias, you have to Google it. When the T is small and the N is large, it will cause auto-regressive bias to the coefficient, right? So how do they do it? They can have many different ways. First, they use first different transformation. First different means you minus, right? First different transformation. But after this first different transformation, the correlation still exists between the different lag dependent variable and the distribution process, right? You have a very, very complicated formula. Myself also cannot remember. You have to let me see only can remember. So never mind. We don't go too into detail. We make difficult things simple. Why you use dynamic model? Because you have this nickel bias, auto-regressive problem, endogeneity, all are same thing. Talking about same thing. So possible solution, right? Even though your first different transformation also cannot completely solve this problem. So your possible solution is this Anderson cell instrumental variable. So you use instrumental variable. Instrumental variable, you see, same thing. XT, IV mean instrumental regression. XT mean panel, IV instrumental, IG regression. So you use panel instrumental regression, then run your equation like just now growth, SG, PG, FO, or thing, then FD. Right? So you run this one, or here's my cursor. But this one also got some problem, right? Or then the latest one or the more popular one, they use the Areno bond GMM. Right? This GMM, of course, have dynamic and system, right? So now we'll focus only on the GMM. Right? This GMM method is created or introduced by this Arellano and bond. So A bond, right? So XT is the panel data. A bond, the two person name, right? So the software command is XTA bond 2, right? So again, if your Stata software do not have XTA bond 2, maybe if you just buy the Stata software as original, completely new, they only have the basic command. So you have to install SSC, install XTA bond 2, then only you have my mouse where, right? Again, you see, the equation is still the same, right? Growth, EG, SG, PG, and then your control variable, right? And up until here, it's the same, right? You only add one more L dot growth. L in Stata or econometric, usually L dot, if L no dot is usually is a name that you use to represent log variable, but is L dot is not a name anymore, it's a command. The command for lag variable, right? leg 1. L means leg 1. Dot growth means the growth leg 1. Growth is your dependent variable, right? So in this case, why you want to run the dynamic GMM? Because this pass of Y also affect the growth. Sometimes they also call this hysteresis phenomena, right? Inflation, usually the use of inflation. Past inflation will also causes inflation. But I want to use a more layman term like your exam mark. Your paper, like yesterday exam result will affect your tomorrow exam or your today preparation and therefore tomorrow exam result, right? As I mentioned just now, if you think fail badly, then you affect your mood, right? Then you cannot study, cannot focus, cannot sleep, so you affect the next one. So the lack of growth will affect the growth. I mean, yesterday growth will affect today growth, right? Then you put the comment GMM. Once you put the comment GMM, they got a lot of inside the system. People already program everything nice. We just put the comment only. So GMM bracket back the same equation again. Growth, EG, SG, PG, FO, all the things bracket back, same thing. Okay. Until now, you see, it's just put back the equation. Now, collapse leg 2, 3. Okay. Ignore the collapse first. Leg 2, 3, they mean we are trying to use leg 2 and leg 3 only. Of course, you can put leg 2, 4, leg 2, 5, right? You can put anything leg. But the problem with GMM is if there is too many leg variable or too many instrumental variable, cannot run, right? Cannot run. Therefore, you have to automatically collapse some of the leg variable that is not significant. You no need to choose. The system will help you to do it automatically. So you put collapse, that means you minimize the leg variable. You only take those that are important, significant, and useful. Those that are not important, they will automatically help you to not to use it. So therefore, you minimize your variable, then only the GMM can function, right? Then of course you put robust, like just now we do the robust cluster, this automatic robust. HT is just the way you choose the effect, how it's been run, H1, H2, H3. You want to know more, you can click the help file in the Stata, you run, right? And then 2 mean 2-step least square. And then important here is dynamic GMM, you put the NOL, not KOL, NOL, no linear regression. If system GMM, just delete the NOL. Just delete the NOL. The whole thing is the same. You just delete NOL, you become system GMM, right? Okay. Later we come back to this one, okay? Again, you see the number of instrument must be smaller than number of observation. If this leg instrument, a lot, leg 2 to leg 10, then the number of instrument is bigger than number of observation. So the GMM cannot run. So you have to use the collapse command and specific leg length to minimize the instrument, right? You try and see, you come out, what you got the red color one, don't know what warning they give you, but they say you cannot run, right? Then again, after you run the model come out, you check the beta for coefficient, the coefficient, you check the beta. So as usual, you check the beta for significant or not. You 3S, right? First is significant. Second S is the sign, positive or negative. Significant, you check p-value. Size, you check sign, S-I-G-N, sign, you check positive or negative. And then the size, how big is this? How many percent? 1% change in X1 will cause 1.2 percentage change. Why? So you see the sign, right? But nowadays, usually the sign may not be that important compared to the significant and size and positive or negative. Okay, then the overall chi-square significant. And of course, dynamic GMM, you got some technicality that we are going to check later on. You're going to check the AR1. Later we will see the result. AR1 means auto-regressive 1, right? That means your original equation got auto-regressive or not. So AR1 must be significant. Common answer will be yes. If you don't have AR1, that means you don't have this endogeneity, you don't have this auto-regression bias, you don't have all of these problem, then why you run dynamic model? It's better to go back to the static model, right? Because static model, dynamic model you run because you have this problem. So if AR1 is not significant, you don't have all this problem, then why must you run dynamic model? So there's a question mark here. Therefore, previous acceptance is AR1 must be significant. But nowadays, it's not important. Significant or not significant is still okay, because we think by theory, right? By theory, previous growth will affect this year growth, right? You cannot be previously we growth 5%, then nothing extraordinary happen, like trade war lah, tariff lah, and COVID lah, nothing extraordinary happen. Last year, let's say we grow 5.6%. This year, you don't expect it to grow 1% or 0.1% or even recession, right? So you expected last year growth will also here or there also will give you some impact. So if you think it's like that, then by theory, this one no need to be significant. Also, you can justify that why you choose the dynamic GMM. Okay? And then AR2 must not be significant. Why? Because GMM or dynamic model is to overcome this problem, autoregressive problem, right? Endogeneity problem. This endogeneity problem is because of the autoregressive problem, the AR problem. So if your AR2 after you use the dynamic model, your AR2 is a final version, still got problem, still significant. That means you need to run a dynamic GMM, right? So AR2 must not be significant, because if AR2 not significant, if AR2 is significant, that means your problem here has not been solved, right? If your AR2 is not significant, that means the problem here, or that means the justification for you to use a dynamic model, the problem here is solved. So you must remember, AR1 previous paper, you see the very old 10 or 20 years ago paper, they say must be significant. But in recent one, they may say that may not need to be significant. But most important is AR2 must not be significant. Okay? Then you use the Hansen test to choose whether you use dynamic or you use the Hansen test to see either any overriding restriction, right? And again, must not be significant. All this has Hansen test. Hansen test is also a diagnosis test for GMM. Again, diagnosis test must not be significant. If significant, that means got problem. Okay? Okay. Then if you do the testing, you'll get result like this. Later we'll show. And you'll get result like this. Hey, what happened? Two step, right? Two type different GMM in DGMM, right? So the whole model silicon you see here, probability chi-square 0.000 means significant, right? If 0.03, that means it's significant as 5%, not significant at 1%. Okay? So usually significant, right? Then dependent variable is growth, independent variable and control variable. 1, 2, 3 is independent variable, then 4, 5, 6 is control variable, right? Then you see or not, L dot, this one is a growth lag dependent variable is this one. Okay, so from here you notice that lag dependent variable is significant. It's not surprising, it's a good result, right? Because if this lag dependent variable is not significant, then you come back to your reason why you must use dynamic GMM. Then you use dynamic GMM because you think this lag dependent variable is significant, you affect the model, right? So you take out explicitly like that. If this one is not significant, that means you delete this one. Look familiar, right? It's just like a static model, correct? So this one most likely is significant, and or in this case you need to be significant. Then your AR1 and AR2 you see from here. Another test for AR1 in first difference, here significant. Here got a little problem lah. Here also significant, right? So here significant, I mean justified that you used dynamic model. Here, of course, you can say that it's not significant at 1%, but in this case, you may have you will see that this dynamic model cannot really solve the problem because it's still significant at 5%. But if you take it as 1%, then you say it's not significant at 1%, no? Right? So it's not significant at 1%, that means you can use this result. Okay? Then Lagan test, Hansen test, usually you see Hansen test. This one must not be significant. But these two are actually alternative tests. Here, that's why you see this model got a little bit of problem because here is significant, here is not significant. Usually you'll get the same. So Hansen test is just like a diagnosis test. Diagnosis test I mentioned is now significant mean no good, not significant mean good. So in this case, not significant mean good, right? You don't have overriding over identification problem, right? Good. But be careful, as mentioned just now, cannot equal to 1. If Hansen test equal to 1, that means this whole thing got some problem. The whole model got some problem. This one must be not significant, but cannot be equal to 1.0000000. Okay. Later on, we run everything in practical, so we see the truth. So you type this comment inside, right? Or we type this comment inside lah. Okay. You type this comment inside, you come out exactly the same thing. Okay. And this comment again, you see that these are the your standard model, right? Equation, dependent variable, independent variable. You need to add L growth because your dynamic model say that the lag growth actually got impact, right? You put a comment GMM here. Again, this extra bond tool, if you cannot, then you have to install. Okay? Again, the same one. You put the collapse here actually to let the Stata automatically help you to delete all the not so useful lag, right? So you restricted your lag to 2 to 3 or 2 to 4, 2 to 5. Then this one robust, automatic give you robust already. This one you don't need to care about it first. Then 2. Got problem or not? I think copy. Oh, system we have copy wrong already. I want system GMM. Okay. This one is system. Okay, you see, just here 2 only. Where is the NOL? You see no NOL, right? So if no NOL, you see what happened to the result? What's the result? System GMM. Can see or not? If you put NOL, okay, now I put back the NOL inside. NOL. If no NOL, here no this whole comment no NOL, right? It becomes system GMM. If I put the NOL here, right? Then you become different GMM. So the difference between different GMM and system GMM is one got NOL, one don't have NOL. NOL means L here even linear regression. NOL here no linear regression. Okay. So what's the difference? So this one is you use 2-step different GMM. You differentiate already. That means you don't have the original. Different means T2 minus T1, T3 minus T2, T4 minus T3. You differentiate already. So you don't have the linear regression already. But then you notice that the whole relationship actually is about linear relationship, right? It's not about different relationship, right? So therefore, if you deleted this no linear regression, it seems like got something wrong somewhere, right? Regression is like, what is the relationship between EG and growth? It's not what the relationship between first difference of EG and first difference of growth. So sometimes you might feel that even though it's representable, you feel it NOL, no, this linear regression is still important. So therefore, you don't put no linear regression. You don't put no linear regression, that means you want linear regression. So if you want linear regression, you delete this NOL, then you delete this NOL, you get system GMM. Okay? Right? So you interpret the same, right? So here you see, not significant. This one got problem, but usually we prefer this Hansen. Okay? See, AR1 significant. Yes, very good, because you need it to be significant, right? But here also you see it's 0.48. you can consider it as not significant at not 1%, not 5%. If 5% is still significant, you should consider as not significant at 1%, right? But this is an example only. Of course, you have to adjust. If you get this one, then people will question you. So you interpret not significant, not significant, not significant. You see, something wrong with this one. You see, this one is 0.48, even though you can say it's significant at 1%, it's not significant at 1%, but it's still significant at 5%. As we say that we cannot have AR2 significant, right? So if you have AR2 significant, your result come out will also not be that nice, right? All not significant except this one only. So except the lag variable significant only. So if only lag variable significant, why not you just run the AR1 model or AR2 model, ARIMA model, then it's settled, right? So you see all this not significant. So from all these statistics, right, you know that this model is not really that good. Okay. So here also the same. Here also the same. Okay. System GMM. System GMM. Okay, let's first. We see until here first. Not significant, good. This one is better. You see, 0.200. So it's very clear cut, not significant at 1%, not significant at 5%, even not significant at 10%. So this one look better. Okay. AR2 must not significant. Okay. And then you notice here, at least you got one item significant. Or not. From the diagnostic test, you already can estimate whether this model is better or which one is better or how good is it, right? So you see, in this case, only got one significant. Compared to your static model, you got a lot of significant, right? This one is dynamic model, you only have this one significant. Okay? And then here, the lag variable also very significant. Okay? So far, okay. Now, next, you have two different system, two different dynamic model. One is different GMM, one is system GMM. How do we choose? You should choose which one. But from what we can see here, seem likely that the system one is a better choice lah. But is this the correct way to choose? You agak-agak, you think this one should be the better choice. No. You have a method to choose. You see, yeah. So, like I said, system GMM, you delete the NOL, right? System GMM include the level equation, right? Thus delete the NOL. NOL stands for no level equation to make it a system GMM. Same thing, you just don't have the NOL, right? Similar interpretation, check coefficient, check overall model, check overall significant, then check AR1, AR2. AR1, nowadays I think the new style, they may not really so important whether it's significant or not, but AR2 must be not significant. Then Hansen test is just like your diagnosis test, must be not significant. Then you get the thing is overall model coefficient. Before you interpret the coefficient, you check the significant first. Okay, if not significant, don't interpret the coefficient as EG has positive relationship with growth, even though or not significant. Or some I see that it write like economic globalization has positive but not significant relationship with growth. So positive but not significant relationship, it means equal to no relationship lah. Okay. So when you say SG has negative relationship with growth at how many percent? In this case, it's at 1% significant level. So you interpret in terms of significant, sign, positive or negative, and then the size lah. If it's necessary, then you interpret size. For example, if this is significant, right? So because it is in ratio, right? So one unit change in social globalization, this growth in percentage, right? So will cause a 0.193% or 0.19 percentage drop in the GDP. That means your social globalization increased by 1 index point, right? Then your growth actually dropped by, if growth in percentage, right, dropped by 0.19%. Right? Okay? So you can interpret in terms of size. Okay? then lag-dependent variable, then AR1, AR2, and then the Hansen test. Then next, you see here, for the different GMM, right? Usually you only have up to here. For the system GMM, you see you have this one, different in Hansen test of exogenality of instrumental subset. So this part is actually help you to choose between different and system GMM. Okay? Now wait. Now DGMM versus SGMM. Which one should we choose? Of course, sometimes you just based on your experience, or you can sometimes some paper they present both, right? Especially if all the result is about the same. But yet there's a systematic way to choose. So first, you just see the different in Hansen test of exogenality like just now. If do not reject, imply SGMM is preferred. This part, the below here, probability do not reject. Okay? If you see back the Stata, just now the system GMM is where two-step system GMM. Okay. Of course, this one you can adjust either bigger or smaller. Okay. This one either bigger or smaller. Okay. System GMM. Where? This part. Okay. This part is for you to choose between system GMM or different GMM. If this one is not significant, that means the rules of thumb is to choose. Wait. If do not reject, imply system GMM is preferred. So from the test here, is do not reject, right? 0.04 probability is do not reject. So imply that system GMM is more preferred than the system from the different GMM. I mean the S GMM is more preferred than the D different GMM. But from here also, you know that the diagnosis test, the system GMM is no nicer than the different. Okay? So this is the official, this is the systematic way to choose. First method. Second method is you compare the coefficient. This one will be a little longer work lah. Comparing the different coefficient of a lag-dependent variable of DGMM with the pool OS upper bound and FE lower bound. So you generate this one. You generate this one. Right? This one just now we do before, right? But now we do again. This one put code line. Okay. So the difference of this one with just now that one is you have the fixed effect Crawford cluster, right? You done before is you have add on one more this one, lag growth variable. Okay. Therefore, you see why you need to do a dynamic model. If you think that only this one is significant, you can also do like that. Just put one more item here, right? Right. So sometimes also got question, of course, in the econometric thing, got on one hand on the other hand. But never mind, we do this one. You run this OOS, right? Then you check the coefficient of the lag dependent variable. So for the coefficient of the lag dependent variable for this one, okay, this one, is this one right? This one, lag dependent variable, the coefficient is, remember, 0.3131, very easy, 0.3131, okay? Then OOS is, this one is 0.3131, okay? Then fixed effect. This fixed effect, so this one is fixed effect. Where? Oh, just now is fixed effect, right? This one is fixed effect. This one is FE, right? Fixed effect. This fixed effect, the coefficient for random variable is 0.3131. Just now the random effect, just now the pool FS is what? We run already, now I already got the number here. So fixed effect 31.31, 3131, and then you run this one for the pool OS, you should get 0.5266, right? So remember, the coefficient for the pool OS is considered as upper bound. The coefficient for FE is considered lower bound. So you get the coefficient for this variable, the lag dependent variable, then you get like that. This one, okay? So the upper bound, the lower bound. So the coefficient between DMM is 0.2617, which is lower than the FEM lower bound. So you see, this one is a lower, this one is upper. The DGMM coefficient for the same lag variable is 0.26, which is below than the lower bound. So you see, this is the lowest, this is the highest, pool is the highest, lowest, highest. This one is even lower than the lower. So most likely it's not rejected, it's rejected, right? So lower than the lowest, I mean it's not between these two number. So therefore imply that DGMM estimate is downgrade bias due to weak instrumental. So therefore SGMM is preferred. So these two model didn't contradict with each other. So method 1 and method 2 didn't contradict with each other, because now we have this Stata automatic run out. So you just look at the result here is faster, but you want to have a double check, you can use a more complicated, you need to do more things, right? So the method 2, you notice that you give you the same result, system GMM is more preferred. So you can use two methods to choose, or at least to justify that you use which model. So in this case, if your SGMM is more preferred, so all your interpretation, right? All your interpretation should be based on the system GMM, right? So not based on the different GMM. Okay. Alternatively, right? You can use XTD PDSY system GMM. You can use this command to run your system GMM. So it's still about the same concept. You see, you have the command on the first one, right? The first tag the word is the command word, then followed by your model or the equation, group, dependent variable. Then this one I copy from a different one to be the EG, right? This one followed by your independent variable, and then your control variable. So it's the same thing. This one is the model, right? Instead of you have so long, you see this one, instead of you have so long, the equation is so long, right? So long, then you can use, if you want, you can use the shorter way. You just put maximum lap, 2 step, and then robust. You can use this command to run your system GMM. Okay. So it's an alternative things lah. Okay. So far, any question?